Nuclear power currently. Nuclear power currently supplies 16% of Britain's electricity. However, since 2006 there has been a drop of approximately 4%. From this source, 70% of the UK's low-carbon electricity is produced, preventing the release of 40 million tonnes of CO2 annually in the UK. With 30% of the UK's coal and oil-fired power stations due to close by 2015, the UK will require an estimated 60,000 megawatts of new electricity. Britain confirmed in 2008 that it would back a new generation of nuclear power station. Without this new generation of nuclear power, many believe the UK won't be able to meet its energy demands whilst preventing the emission of carbon dioxide from increasing. Alongside the UK, France is strongly dependent on nuclear energy. It generates 75% of its electricity from nuclear power. A big supporter of nuclear power outside of Europe is China, where air pollution due to burning fossil fuels is estimated to kill 750,000 people a year. Around 30% of China is found to be polluted by acid rain, the result of sulfur dioxide from coal-fired power stations. At current rates of production, China can only continue for 38 years before coal reserves run out. Nuclear energy is not just used as a form of electricity, but as major weapons. Only recently have sanctions on Iran been lifted. It was recently discovered that Iran had built a secret facility with approximately 3,000 centrifuges to enrich uranium. A single nuclear power plant could produce enough enriched uranium for 10 to 30 nuclear weapons annually. With the threat of nuclear power being used as a weapon, the decommissioning of plants has been a major focus point. This cost is approximated to be 9 to 15% of the initial cost, yet in Britain's case this would total over £100 billion. For the United States to get 1/4 of its total energy supply from nuclear power, it would require 1,000 new reactors. However, it has been proven that an increase of 8% in burn-up will reduce fuel costs by 5%, as well as saving 8 million tonnes of carbon emissions per annum. A golf ball-sized lump of uranium could supply the lifetime's energy needs of a typical human being. Currently, uranium is consumed at 68,000 tonnes per year, yet there is only 5.4 megatons available. This would provide mankind for only 80 years, yet it yields 20,000 times as much energy as the same mass of coal. The design of new nuclear power plants should hopefully enable them to last for 60 years, compared to 30 to 40 years for most gas and coal stations. MIT reports that we could avoid 1.8 billion tonnes of carbon emissions annually from coal plants by increasing nuclear generating capacity by threefold to 1,000 billion watts by 2050. In the United States, a 2009 survey by Washington-based Nuclear Energy Institute found that 38% of nuclear industry workers were eligible for retirement by end of 2013. This led to a 2-year education and training program in technical colleges across the country. It is estimated that there is a need for 1,200 graduate students in the field of atomic energy annually for the next 20 years, yet there are only currently 300.